Hello, this is a video on composite functions. It's the second part of section 1.7 in your PreCalc 1 textbook. There is another video that is on the first part of this, which is more focused on domain and algebra functions. So let's get started. What is a composite function? So we write a composite function as this f with this little circle g and then x. And we read this as f of g of x, or the composite of the function f with g. And what this really means is that we plug g of x into f of x. So wherever we see x in f of x, we're going to substitute the whole expression for g of x. Let's take a look at an example. We have f of x is equal to 4 divided by x plus 2, and g of x is equal to 1 divided by x. So if we want to find f of g of x, we're going to take our f of x, this is 4, divided by where we see x, we're going to replace g of x. So this is x plus 2, but we have to plug g of x, 1 over x, in for x. Okay? So now this first part, we don't like we don't have quotients inside of quotients. So this is the immediate substitution, but let's go ahead and multiply our numerator and our denominator by x so that we don't have quotients within quotients. And when we do that, we get 4x divided by 1 plus 2x. Okay? This is our composite, f composite g of x. And that's what we're doing when we do a composite function. Please note that order matters. F of g of x is not the same thing as g of f of x. So you have to pay attention to the order there, okay? So when we evaluate the domain of these composite functions, the first requirement is that the domain x must be in the domain of g of x. So let's take a look at that. We have g of x equals 1 over x. Well, we can't divide by 0, so our denominator can never be equal to 0. In this case, our denominator is a simple x, so we have x cannot equal 0. So that satisfies this first requirement for the domain. The second requirement is that g of x must be in the domain of f of x. So we need to take a look at f of x. We have 4 over x plus 2. And again, our denominator can't be equal to 0, so we need to exclude where x is equal to -2. That will give our denominator. But we don't want x, we want g of x. So we need to find the value of x such that g of x is equal to -2. So we have 1 over x does not equal -2 for our exclusion. So we multiply both sides by x, we divide by -2, we get x equals -1/2. So we need to exclude -1/2. So this is the value that makes that gives a g of x that's not in the domain of f of x. And this is the value where g of x is not, or x is not in the domain of g of x. Okay, so we have to look at both of those. So when we take a look at this, we need to, if we want to write the domain of this, we need to exclude -1/2 and 0. So we're going to start at -infinity, go all the way to -1/2, and then we can go from -1/2 to 0, and then from 0 to infinity. Sorry about this. My stylus isn't working very well over here. Okay? So our domain is x must be in the domain of g of x, and g of x must be in the domain of f of x. So any value of x that gives a g of x that's not in the domain of f of x, we have to exclude that value as well. Okay, the other thing that you will be asked to do, is decompose a composite function. So what does that mean? We might be given this function h of x is equal to 3x minus 1 to the 4th. We want to say, we want to rewrite, I put this, h of x such that we have a composite function. So g of x. So when I think about this, I always think about an outside function and an inside function. And the outside function here is always going to be like the thing that you would mathematically do last if you were computing it. That's this, sorry, that's this to the 4th power. So that's going to be our outside function. So that's always going to be our f of x. Right? Then our g of x is going to be whatever is inside that outside function, or whatever we're raising to the 4th power. So in this case, our g of x is going to be 3x minus 1. Okay? And we can do all sorts of things. The common things that you'll see is you'll see like a square root or a root of something inside. I'm just going to put g of x. So the square root will be our f of x, and then the expression inside will be our g of x. Sometimes you'll see absolute values, and in this case, our f of x is going to be the absolute value of x, and our g of x is going to be the expression inside that. We also see, very much like in this example, we have g of x. We have it raised to some power. So the power is going to be our f of x, and the expression inside is going to be our g of x. We might see something like 4 over g of x. So g of x is going to be our expression in our quotient, and our f of x is going to be 4 over x. Okay, so there's all sorts of ways of looking at this, but we're looking for an outside function and then an inside function when we're looking at composite functions. Okay, I hope that's helpful. I think that's all I have for this section.